So this was February March 2016, paper 4, variant 2. So the table gives information about the particles. So complete the table. First line has been done for you. If this particle is having a charge of -1, so it means it is having more electrons. And how many electrons are extra? One extra electron is there. So if there are 18 electrons, then how many protons should be there? 17. Because the charge is negative, it means that electrons are more. If charge is 1 negative or -1 or 1 minus, it means 1 electron is extra. This one is a neutral, so when particle is a neutral, it means it is having equal number of proton and electrons, so it will be 18. And the number of the proton and electrons are given. Electronic configuration means how electrons are arranged. So we have to arrange 10 electrons. First shell we will have 8, and first shell, sorry, we'll have 2, and the second shell will have 8. Then the charge on the particle, how to identify the charge on the particle? There are 8 protons and there are 10 electrons, so 2 electrons are extra. So we can say -2 or you can say 2 minus. That's the same thing, it does not make difference. So if protons are more, it will be positively charged. If electrons are more, it will be negative charge. Then group 3 element is there. Define the term element. So try to learn the standard definition. Don't try to write the definition in your own words. So what is the definition of element? Element is basically a substance that cannot be broken down into simpler substances. So that's a standard definition, and I shared already the definitions with you. So it's better you learn the standard definition. Don't try to write the definition in your own words, because definition is like a solid mark, so you should score those. So substance that cannot be broken down into simpler, or substance cannot be broken down by a chemical reaction into simpler substance, that's called element. Then the following are gallium atoms. So complete the table. How many protons are there in gallium? 31. This bottom is representing a proton number. Here also proton. How many neutrons are there? To get the number of neutron, it will be 69 minus 31. So 69 minus 31, that is equals to 38. And 71 minus 31, so that is 40. And number of electron, because there is no charge on them. If there is no charge, it means they will have equal number of proton and electron. So 31 and 31. Carbon dioxide and silicon 4 oxide are group 4 elements. Complete the table. Formula of carbon dioxide. Carbon and dioxide means 2 oxygen, so it is CO2. Physical state at 25. So the melting point is given. The melting point of silicon 4 oxide is 1610. And we want to find the state. So we know state of a substance before its melting point, it is solid. Between its melting and boiling point, it is liquid. And after the boiling point, the substance is gas. So what are the state? Because the silicon 4 oxide is having a melting point of 1610. So at 25, where 25 will come, 25 will be here. So at 25, what will be the state of the silicon 4 oxide? It will be solid. Then conduction of electricity, covalent compounds as well as elements which are having a covalent bond cannot conduct electricity except graphite. So silicon 4 oxide, non-conductor, does not conduct electricity. Then structure, like covalent compounds, covalent substances or covalent structures can be. Covalent means when two or more non-metals are attached, we call that as a covalent. And covalent structures are divided into two categories. One is called a simple molecular, another one is macromolecule or giant. So simple molecular means which is having a finite number of atoms. Like in carbon dioxide, there is one carbon and two oxygen atoms. So how you will identify the structure? So remember, in your course you learned three of the giant covalent structure. Which are the three? You studied about diamond, graphite, and silicon 4 oxide. So these are the three giant covalent structure. Rest, if any covalent substance is given, that will be simple molecular or simple covalent structure. Why simple? Means it is having a finite number of atoms. So carbon dioxide, one carbon and two oxygen are there. But in case of silicon 4 oxide, it is not like this. The silicon 4 oxide, one silicon, then four oxygen atoms are attached, then one silicon, then four oxygen atoms are attached, one silicon, then four oxygen atoms are attached, one silicon, then four oxygen atoms are attached, and so on. So silicon 4 oxide is a macromolecular giant. So three of the giant structure you have to learn: diamond, graphite, and silicon 4 oxide. So if anything other than that is given, it means what will be the structure? It will be, first, both are covalent because carbon and oxygen non-metal, silicon and oxygen also non-metal. So both are covalent substances, and covalent substance can be divided into simple covalent or molecular covalent or giant covalent. So here in case of carbon dioxide, it is a simple covalent structure which contain one carbon attached to two oxygen atoms only. Name the type of bonds that exist between atoms of silicon in silicon 4 oxide. So silicon is a non-metal, it belongs to group 4, so it is a non-metal. Oxygen belongs to group 6, that is also a non-metal. So whenever two non-metals are joined together, when two non-metals are linked together, they will always have covalent. So the type of the bonding, that will be covalent. Explain why silicon 4 oxide is having a high melting point. Whenever you compare the melting or the boiling point, like if they say high melting point is there, what is the reason? So you will mention strong bonds are there in the structure. There are strong bonds, so it needs lot of energy to break the bonds. So here in this case, what is the reason? You will mention there are strong bonds, so which require greater amount of energy to break. So strong bonds which require greater amount of energy to break, that's why we call that's having a high melting point. Same thing, if the same question was there, why carbon dioxide is having a low boiling point or low melting point? Mainly carbon dioxide sublimate, so CO2 is there. If they say why low, so the reason, what will be the reason? You will mention because weak force between the molecules which can break down easily, that's why it will have low melting point. Explain in terms of attractive force between the particle why carbon dioxide is has a very low. So attractive force between the, again the same question is why it is very low, because there's a weak force between the molecule, so it needs a small amount of energy can separate them. In terms of particle, why carbon dioxide is non-conductor of electricity. Conduction of electricity depends on two things. It depends on ions, free ions, and electrons. So if carbon dioxide does not conduct electricity, it means there are no free ions or no free electrons. So if it can conduct electricity, it means it will have free ions or it will have free electrons, so it can conduct. But as it cannot conduct electricity, so it means it does not have any free ions or electrons. That's why it cannot conduct electricity. Suggest a chemical equation for reaction between sodium hydroxide and carbon dioxide. So what will be the product? when sodium hydroxide is reacting with carbon dioxide, basically it is like acid base reaction. Sodium hydroxide, what is the formula for sodium hydroxide? It is base, NaOH. Carbon dioxide is CO2. So when we compare the nature, so NaOH, sodium hydroxide reacting with carbon dioxide. Sodium hydroxide, what is this? Acid or base? Hydroxide is there. Sodium hydroxide contain OH. What is this? Acid or base? So it is a base, that's right. So sodium hydroxide is a base. Carbon dioxide, non-metal with oxygen, and carbon dioxide is acidic oxide. So when acid react with base or acidic oxide react with base, what will be the product? The product will be salt and water. So when it will react, it will produce salt. So it will produce carbon dioxide, give carbonate salt. So it will produce Na2CO3 plus water, that will be H2O. So whenever acid or acidic oxide react with a base, it will give salt and water. So carbon dioxide gas is there, that's why carbonate salt is formed here. And plus H2O. Then we balance, 1 mark is for completing an equation and 1 mark is for balancing. So this equation is balanced as well as correct in terms of product. So when acidic oxide or acid react with a base, the product is salt. As we discussed already, salt and water will be there as a product. So carbon dioxide mixed with sodium hydroxide gives sodium carbonate, the carbonate salt, plus H2O, water will be there. The reason why it's of 2 marks, 1 mark is for the correct product and the second mark is for the balancing. Name the type of chemical reaction in which carbon dioxide is produced from the fossil fuel. So when we produce carbon dioxide by burning the fossil fuel, what we call? We call that as a combustion, or we can also say burning. Because we burn coal, we burn hydrocarbon that produce carbon dioxide. Name a chemical process in which green plant convert carbon dioxide into carbohydrate, so that is known as photosynthesis. And name a chemical process in which living things produce carbon dioxide, so we call that as respiration. The first part, name type of chemical reaction in which carbon dioxide is produced from fossil fuel. Fossil fuel means like coal. So when we have coal, we burn in the presence of oxygen. It produces carbon dioxide. So what we call this reaction when coal is burned in the presence of oxygen, we call that as combustion, burning. Same thing, fossil fuel can be methane. If we have methane, methane is a hydrocarbon. So when we burn methane, as a result, it will produce carbon dioxide plus water. So it produces carbon dioxide and water. So this reaction, whenever we use oxygen to burn something, what we call that? We call that as combustion. So both the reactions are refers to combustion. And coal, methane, crude oil, or, or petrol, these all are fossil fuel. So fossil fuel we burn and it produces carbon dioxide. That's why we call combustion. Hydrogen peroxide decomposes into water and oxygen in the presence of catalyst. What is meant by catalyst? Catalyst is a substance which alter the rate of reaction or change the rate of reaction. That is 1 mark. But without chemically used up. Like it chemically, it does not change. Some of the students are writing catalysts are enzymes. That will be wrong. Why? Because enzymes are also catalysts. Enzymes are biological catalysts. In biological system, catalysts are known as enzymes. But here, when we are using manganese 4 oxide, so manganese 4 oxide is a catalyst, and this manganese 4 oxide is not enzyme because it is not used in a biological system. It is used for chemical decomposition of hydrogen peroxide. So catalyst is a substance which alter, yeah, speed up, change here, alter the rate of reaction or speed up. I just mentioned the term change here, which I mean it alter or change the speed of reaction without chemically used up. Catalysts are not enzymes. Enzymes are catalysts. Enzymes are biological catalysts. So for catalysts, you don't say that catalysts are enzymes. That will be wrong. Enzymes, in like when catalysts are used in biological system, they are known as enzymes. A student studies the rate of decomposition of hydrogen peroxide using the apparatus shown. The student uses 20 cm cube. So student use 20 cm cube of hydrogen peroxide of concentration 0.1, and he uses 1 gram of manganese 4 oxide. The student measure the volume of gas given off at regular interval. That's because oxygen gas is given off and student recorded the volume of gas. When is the rate of a reaction highest or the fastest? So when in the beginning or at the beginning, the rate is always the fastest because we'll have more particles. So you can mention at the start or the beginning, the rate is fast. Suggest one method of increasing a rate of reaction. So what we can do, if I want to increase the rate of reaction, I can change the amount of catalyst, I can change the size of the catalyst used here, or I can increase the temperature. For any reaction, the rate is fastest at the beginning. Whenever, yeah, for any reaction, because in the beginning you will have maximum number of the particles, so it will always faster at the beginning. So what we can do, we can increase the temperature if we want to increase the rate, or we can use greater amount of catalyst, or we can increase the size surface area of the catalyst by using a powdered catalyst. So these are some ways by which we can change the speed of reaction. For any question you want me to repeat, and just let me know, so I will repeat at the same time. The student carries out second experiment to investigate whether another substance, copper 2 oxide, is better catalyst than manganese 4 oxide. We cannot say pH, that is right. Why we cannot say pH? Because these are not normally, like most of the reaction, biological reactions in which the molecule completely change, the geometry of a molecule change, that is affected by pH. So the student carry out the second experiment investigating another substance which is copper 2 oxide and is better catalyst than manganese 4. He want to find whether copper 2 oxide is better catalyst than manganese 4 oxide. Describe how second experiment should be carried out. You should state how would you make sure that the catalyst is the only variable. So how to make sure, because a catalyst is a substance which is chemically remain unchanged. So we want to find, or we want to show that this substance is a catalyst. So we will take equal volume of, in the marking scheme, I removed the answer for this question. The reason was that because I want to check your understanding skills, like how you will write an answer without the reference of the marking scheme. So student carry out, so what his student should do, he should take equal volume of, hydrogen peroxide, because hydrogen peroxide is the substance which decompose. So take equal volume of hydrogen peroxide, or you can also mention take 10 cm cube of hydrogen peroxide. Any specific number can be mentioned here. So we can take 10 cm cube of hydrogen peroxide. That's one thing. Then we will measure the mass of copper oxide or copper 2 oxide, which we want to identify, because whenever a substance is a catalyst, we measure the mass before the reaction and we measure the mass after the reaction. Because to be a catalyst, chemically it should not change, like the mass should not change, and it alter the rate of the reaction. Then we will add copper oxide to hydrogen peroxide. Then we will start the timer or stopwatch and record the volume of gas. In example, 5 minutes or 2 minutes, any specific. And then we will filter to remove copper oxide, and then we will wait again. If mass of copper oxide does not change and it alter the volume of gas given off, or it give out greater volume of the gas, in 2 minutes, it means, or it shows copper oxide is better catalyst. So what we did, we will take equal, like here you can mention 10 cm cube, or you can also mention take equal volume of hydrogen peroxide, measure the mass of copper oxide, then add copper oxide to hydrogen peroxide, start the timer and record the volume of a gas in 2 minutes. Then we'll filter and remove copper oxide, then we will reweight again. And if the mass of copper oxide does not change and it give a greater volume of a gas in 2 minutes, it shows that copper oxide is a better catalyst. Is it clear that how we work out that copper oxide is a better catalyst? Any doubt here till this point? So when substance is a catalyst, chemically does not change and it just alter the rate of reaction.